Hello, everybody. Thanks for coming to my talk about pod security as an afterthought. My name is Alban. I live in Berlin. I'm co-founder and director of Kinvolk Labs. And at Kinvolk Labs, we do consulting services around Kubernetes on Linux, on cloud-native applications. And one of the things we do is security assessments for customers. Some of the tools I will present in this talk are relevant for that, for security assessment. When I talk about pod security, there are many aspects of Kubernetes security. I will not talk about all of them, but only about pod security. So, for example, securing the control plane will not be part of that, or authentication, authorization, and so on will not be part of that. So, pod security is a piece of configuration, security configuration you applied on your workload. And it could be, for example, limiting the pod capabilities. That's what you write in the security context of your pod, or defining pod security policies to limit what user can create as pod, or airbag rules, network policy like the network firewall for your pods, limiting system calls with seccomp, or limiting the user you can use, so to run your workload as no root user, for example. So that's what I mean by pod security, and this is the thing you write in your YAML file. So when you develop, I present this idea of DevOps lifecycle because hopefully when you develop a new feature, it goes by iteration. You don't develop your full project with everything and then you test it, but it's an iterative cycle where you add a new feature, you code it, you build it, you test it, and so on. And for example, if you add a new deployment on a new service, and then you test it individually, and then you deploy it, and so on. And for the security aspect of that, preferably it's the same thing. It means that when you write your new Kubernetes service, you write, for example, network policies for that new service at the same time. And then when you test it, you test your new feature, you test the security aspect of that at the same time. That should make security easier to implement it incrementally, sorry. But sometimes the reality is different. So, for example, at Kinvolk we do security assessments, and sometimes the deployments already have pod security policies, network policies, etc. But sometimes it doesn't have anything, and that makes it more complex to do, because when security is an afterthought, we might have a big architecture with many components in your microservice applications. And it's difficult to understand this architecture when, for example, a new developer is tasked to implement security, and that new developer doesn't have context about the full architecture. So that's, I give a fictive example here. I just look at this Google microservice demo. And when I look at the YAML files, I see 12 deployments, 12 services, but no network policies. And if I were tasked to implement security on that by writing network policies, I will have difficulties because I don't know this application. I don't know which component is talking to which components, and so on. In this context, we cannot, unfortunately, follow the traditional DevOps lifecycle, but we can still do the best we can with still applying the principle of least privilege with the help of some open source tools that I will present. And the lifecycle I will present is similar. We use the open source tools to record the your application's behavior and configuration, and from that automatically generate security policies, for example, network policies. And from this generation of YAML file, for example, that someone can review them, make sure they make sense, before doing a git commit to add them in your code. So the different software I will present will work in this life cycle. Like when you have your full application already existing and you want to monitor them to generate the security policies from that. So I will present those three open source tools: kube-psp-advisor to create pod security policies, oci-seccomp-bpf-hook to create seccomp policies, and Inspektor Gadget has different gadgets, but one of them is the network policy advisor to create network policies. So first, how do I create pod security policies with kube-psp-advisor? This is open source project created by Sysdig. It's available at Sysdig Labs. To install it, you can use this kubectl crew command. That's the way you install most kubectl plugins. And from now on, you can use this command kubectl advise psp inspect. What it will do, it will connect to the API server, to your Kubernetes API, and read some resources there. And from those resources, or from file if you prefer, it can aggregate the information together and generate new resources to send back to the API server. So in more details, it will read different resources like the service account and different workload, all the workloads like daemon set, deployment, replica set, jobs, and so on. And then it will aggregate that by namespace on service account and generate a new pod security policy and role binding for each of them. It means that if you have several pods in the same namespace with using the same service account, it will only generate one pod security policy. I can give an example of that with capabilities. In this example, we have one deployment using the service account SA2, and it needs to have these two capabilities, sysadmin and netadmin. What we want is this service account should only be able to create the deployments that it needs to with those capabilities, but no more. So this tool will create automatically a pod security policy that specifies that it's used for this namespace and for this service account, and it is allowed to create this the pods with those capabilities, but no more. This is another example with volumes. So here we have a deployment with a service account specified, and it has access to some volume, and it will generate the pod security policy that specifies that it's allowed to create this deployment in this way, but not more. In this way, we can restrict what users can create. So they cannot create any pod with privilege, for example, if they don't need to. So this tool supports different attributes from the pod security policies, like, for example, the privilege bit can be restricted if it is not needed, or access to the host networks, and so on. Okay, so now I will talk about how to generate seccomp profile with oci-seccomp-bpf-hook. This is another open source project. And this tool has to be installed on the worker nodes where the container will be executed to be able to use it. And once it's installed, for example, as a RPM or with make install, it will start to monitor the system calls executed from a pod when it has this specific annotation. So this annotation specifies actually where the seccomp policy will be written. In this example, it will save a JSON file called /temp/ls.json. And this is, by the way, a path on the host of the worker node, not in the container. And that's an example of seccomp policy. I took it from the Docker documentation. And it's specified here that by default, everything is denied. That's what it says at the top. It will return error. And then we allow in this allow list the list of system calls that are allowed by the seccomp policy. In this example, it just lists 2 system calls, accept and accept for, that will be allowed, and everything else will be denied. Of course, it's difficult to know what the application needs. So even if we want to apply the principle of least privilege and restrict everything unless it's necessary, it's not practical to write this kind of seccomp policy by hand. So we use this tool, oci-seccomp-bpf-hook. And the way it works is looking at the left first, we have runc that create and execute new containers as instructed, for example, by Kubernetes and Kubelet and Cryo, or by Podman. And Cryo or Podman will instruct runc to start a container with a specific annotation that will contain a oci-seccomp-bpf-hook. So it means that runc, before the container is really running, will execute this oci-seccomp-bpf-hook, and it is configured to run oci-seccomp-bpf-hook. It will receive the OCI state on stdin. It means it will know the PID of the container, and then it will execute itself in the background so that it can install a BPF program. And that BPF program is hooked on the Linux tracepoint sys-enter. It means that the BPF program will be executed for every single system call on the system. But the first thing the BPF program will do is apply a filter on the container one namespace. That means that it will only gather information for the system calls that are performed by the container. So not things on the host or different container, but only the container we care about here. In this way, by specifying the annotation on the container, we can catch all the system calls from that specific container, and the BPF program will send those information back to oci-seccomp-bpf-hook with this system call data that it will then write into this into a file that is the seccomp policy in JSON. So the general workflow for the developer is to start an application with this BPF program, catching the system call event, and exercise different features of the application and hoping that it will cover most of the code path to capture all the system calls it needs to have access to. Then once you have your seccomp policy, you can use it to put it in a pod YAML or in your pod security policies to say I want to execute this pod with this seccomp policy. And finally, I will talk about how to generate network policies with Inspektor Gadget, more precisely with one of the gadgets of Inspektor Gadget that is called Network Policy Advisor. So first, that's open source project as well that is available on our Kinvolk GitHub repository. And it can be installed in the same way as many kubectl plugins using this kubectl crew command. And once installed, you can deploy it on your Kubernetes cluster. And then you can use the two following steps to generate network policies. First, you can use it to monitor all the new connections that are happening on your cluster and generate a log of those connections. And from that, taking that as a pattern to generate the network policies. How it works internally, it will use BPF programs and attach it on kube-probs. Kube-probs means it will the BPF program will be executed for every call of the specific kernel functions. And it uses internally this TCP tracer BPF program. That's something that Kinvolk developed for WeaveWorks initially, for WeaveScope. So this program installs kube-probs on different kernel functions like TCP connect or TCP accept and so on. And then get the aggregate this information about connections and generate a log. And then this log can be used to generate network policies. So in more details, the first step, it gets information both from BPF about the TCP connect and TCP accept events, and it will also read information from the Kubernetes API so that it knows the label for pods and for services that will be useful later to generate the network policies. From that, it writes a connection log. This connection log will contain one line for each connection, with some details, enough details about the labels and so on to generate the network policy later. So this is done online in your Kubernetes cluster. And the second step can be done on your laptop offline without access to the Kubernetes cluster. It will just read the connection log, this JSON file, and then aggregate that by namespace or label to generate network policies. It means that if you have many connections that are identical from the same port to the same port on the same TCP port, for example, that will of course generate only one network policy for that and not as many as connections. I give an example here. Here, that's an example of JSON file representing one connection. So I see that this front-end pod connected to the checkout service on Kubernetes, and it has some information about the labels that is enough to generate the network policy here. So in this example, it generated an egress network policy. That means that this front-end application is only allowed to connect to this checkout service on this specific port. And that's a bit the same thing as the previous software I presented about seccomp. We want to let the cluster run and go to most of the code paths to generate all the TCP connection, for example, between different components, so that our tool can catch those events and generate the necessary network policies. Of course, that's not something to apply blindly on your cluster. You cannot just say, okay, I generate network policies and I can just apply it without thinking about it. Because there might be more connection that are necessary if you don't go through all the code paths. But still, I find it really useful to use that, because instead of starting your network policy from scratch on a big microservice application I don't know anything about, I can use that as a starting point and look if it is sensible and maybe do some small adaptation if necessary, but without starting from scratch. So thank you. That's the end of my talk, and I can reply to questions. Hello, everybody again. I will go through the list of questions. The first question from Nikhil Srivastava. kube-psp-advisor, how does it know there are redundant or extra privileges that should be removed? So first, the kube-psp-advisor doesn't know, it doesn't actually look into the process that are executed in the pods. So it doesn't know if there are capabilities that is exercised or not. The only thing it looked at is the pod definition on the pod demand set and so on definitions. For example, in the YAML file, it will see if there is a request for a capability. And if this request is in the resource definition, then it will use it to create the pod security policy. So that's it might be that you have a pod which requests kube-sysadmin, for example, even if it is not needed. Then when the pod kube-psp-advisor will look at that, it will say, it requests kube-sysadmin, so I will create a pod security policy with kube-sysadmin. So that might not be what you want, but that's how this tool works. There are other tools to actually look at the capability really exercised by the container. in Inspektor Gadget, there is a capability tool that works differently. It's a real-time tool. You can see the stream of capabilities that are attempted to be exercised by the applications. But it doesn't generate the PSP for you, so you can look at it and see if they are actually exercised or not. Another question from Dixon Dalmeida: which is better, pod security policy or OPA gatekeeper? First, I don't know much about OPA gatekeeper. The only thing I know is that pod security was announced that it will be deprecated at some point by Kubernetes. So I would expect that the second OPA gatekeeper will be the one that is more long-term. And the thing I know is that OPA is more flexible in the way you can describe rules with a custom language, and PSP is more constrained in the way you can write rules. But I don't have more opinions to say about this now. Another question from Julian Camilo Cuevas Alve. Does Network Policy Advisor work with Istio, FOST, MTLS, on authorization policies? So first, I've never tried it with Istio, so I don't have hands-on experience with that. So the Inspektor Gadget Network Policy Advisor doesn't know anything about Istio. So what I would expect it will happen, it will manage to write Kubernetes network policies, but it will not generate any Istio-specific policies. So it will not do what you want, I would expect. Still, that might still help you to know which pod is talking to which pod, but that will not help you to know the layer 7 information to if you want to see the HTTP endpoints, for example. Another question: why is PSP cluster resource? Cannot it be namespaced? So that's true. The PSP is a cluster resource in Kubernetes. I don't know the origin of why that is, but I would expect that since it's there are security sensible things in PSP that act on a node level. For example, if you restrict the capabilities or if you restrict the host volumes, there are things that affect the node itself, and the node is not a namespace resource as well. So I will guess that's come from that, but I'm not sure. Another question: does Inspektor Gadget need to be fed with the data with all connections, or does it know all connections allowed and rest to be denied? Inspektor Gadget can look by itself the connection that exists, so it knows when there is a new TCP connection between this pod and this pod, for example. So in the first phase, it fetches the information itself. You don't need to tell it. But it doesn't know if the connections that happen are actually good or bad. It only assumes that all the connection you do during the phase of training is good, and you generate the policies for that. But then you should review that and check if it actually makes sense. In case there is a connection that doesn't make sense, that has happened, and you want to plug it. So it can fetch the information by itself, but it doesn't know if it's good or not. Another question. How do we override the network policy already created? It might be recreated again and again. Yes, that's true. At the moment, the Network Policy Advisor is optimized for use case where we have an application already that doesn't have any network policy, and then it's used for the first time we create network policies, but then it doesn't actually reconcile or do anything with the already existing network policy on the new one that are suggested by Inspektor Gadget. So that's something that it does at the moment. On the other hand, there is a GitHub issue open about that to read the existing network policies and see the new one suggested and see to make suggestions. That's more difficult to do. That's something that has been thought about by Mauricio in the Gardener project, but there is no code at this stage. There is just an idea of algorithm how to do that in a GitHub issue. Let me read other questions. There is another questions about allowed host path versus no host path at all. Why does the kube-psp-advisor complain about host path? I'm not sure I understand the question actually. I understand the question as why do we need to care about host path? That allowing a host volume in PSP means there is less isolation between the container and the host. So that's potentially security issue. And there have been in the past some CVE, some vulnerabilities where a PSP, where a host volume allowed the access to a specific path, but because of a vulnerability, it allows more paths than the one declared in the resource. I apologize if I didn't understand the question correctly. Another question from Tadeusz Lucas. As services are added to the cluster, how would you recommend to regenerate the network policies profile or run the profiler? So that's a bit similar to the other questions. So at the moment, the network policy advisor run on a specific namespace. So when you run the monitor, you specify a list of namespaces, for example, the default namespace or namespace of your application, where it should monitor the activity. If you add new services in a different namespace, then you can just run that in that other namespace and get the new network policies. Otherwise, if you run it in the same in the same namespace again, then you will have to the same problem that at the moment there is no way to reconcile that, although there is a GitHub issue talking about that. Another question: runtime sidecar injection, are they bad from security point of view? I think when you inject a sidecar in your workload, then they have the same privilege that the pod running there. So I will say it depends, but injecting a sidecar is a useful pattern for Istio and other service mesh, so that that can add securities as well to use this kind of service. But sorry, I'm having a bit of trouble to go through the question. I think I can read one last question. Where did you learn about eBPF and its policies? So a good resource to learn about eBPF is the BCC repository, stand for BPF compiler collection. So this repository has a collection of BPF tools for networking, for tracing, and so on. And I find that very useful to to read how it's done, to read the different programs there. And it's also has a good documentation about the list of BPF helper functions that are useful when you write BPF code. About its policies, I'm not sure what the question means here. I think I am at the end of the time. So thank you everybody for attending the talk.